Welcome back to Miss Eddie's Math Movies, where it's cute to be a square. Today's lesson is section 5.3, angle, side, angle, and angle, angle, side. By the end of the lesson, you will be able to determine if triangles are congruent using angle, side, angle, and angle, angle, side. So we've already learned how to prove that two triangles are congruent using side, angle, side, and side, side, side. So previously we've learned these. This is how you prove triangles are congruent. And today we're learning angle, side, angle, and angle, angle, side. Let's take a look at what these look like. If two angles and the included side are congruent to two angles and the included side, then the triangles are congruent. So let's take a look here. Here's an angle that's equal. Here's a side that's equal, and here's an angle that's equal. This is ASA, angle, side, angle. So ABC is congruent to DEF. Notice how that side is in between the A's. That's really important. That's the difference between this and this. See here the S is in between, here the S is not in between. So we're going to practice finding the included side. So here's angle T and angle G. Which side is in between them? It's like asking which side are they both touching? That's this side right here. T, G. All right, now let's look at G and L. I'll erase T. Now we have G and L. Which side are they both touching? G, L. Now we've got angle T and angle L. The one they're both touching is TL. So then it says name the non-included sides. All right, well, I gotta draw a triangle. Triangle A, B, C. So angle A and angle B. Well, the included side is AB. That's the one they're both touching. So the non-included would be BC and AC. All right, I want you to finish this. Do this now. You are naming the non-included sides, the ones that they're not both touching. Angle, all right, determine when you can use angle, side, angle. All right, can you use angle, side, angle, yes or no? All right, well, here's an angle, and here's an angle, and then I see they're sharing a side. Remember, whenever they're sharing, that's reflexive, right? Just to remind you, that's reflexive. Is this angle, side, angle? Is S included? Is it in between the A's? Yep, it is in between. The included side between the angles is BC. The included side is BC. We use the reflexive property. Angle A. So we've got ACB is equal to DBC. And ABC is equal to DCB. All right, this was a yes. It's angle, side, angle. And let's see, we have the other, so we just did this angle. Now we need to talk about these two angles. Angle DBC, and that angle right there, angle ACB. Let's look at this. I see an angle that's the same. I see another angle that's the same, and I see a side. But is the side included? This is the side that both angles are touching. That's the included side. The included side is RS, and the included side over here is XY. This is not angle, side, angle. This is angle, angle, side. And we're going to talk about that down below. So here we've got two angles, and the side is not in between them. Side is out here. It's not in between. That's the difference. But it still works. ABC is congruent to DEF. The follow-up says, in part B, can you use angle, angle, side? Well, that's up here. Yes, that is definitely angle, angle, side, because the side is not in between. Determine what information is missing. What additional congruence is needed to show these triangles are congruent by angle, angle, side? Well, let's see what we have already. We have a side. What else do we need? That's what it's asking. Well, oh, I see vertical angles. Anytime you see vertical angles, you put an A there. So we've got an angle and a side. What else do we need? Well, we've got an angle and we've got a side. We need another angle. And this is asking, what else do we need? So now the question is, which angle do we need? Do we want this angle or this angle? Well, it's angle, angle, side. So the side cannot be in between. So if I put my A here, the side is in between. I don't want this. I want my side to be by itself. So this is the angle I need, and this is the angle I need over here. I need angle J to be congruent to angle N. All right, I used my vertical angles already. That's one angle. That was a side we needed. And then we needed angle J and angle N. So this is the additional congruence we need. Does the diagram give enough information to show that the triangles are congruent? If so, state the postulate or theorem you would use. All right, so the postulate or theorems we've learned so far are SSS, SAS, angle, side, angle, and angle, angle, side. All right, let's see. I see a side. Oh, and I see an angle. So that's SA. Well, is there anything else? Oh, you should see your vertical angles. Let's put an A in there. So we've got two angles and a side. Is this angle, side, angle, or angle, angle, side? Well, here's the side in between the A's. So this is angle, angle, side. So now we need to list all the things that we used. See, if we did two angles and a side, we need to talk about two angles and a side. Well, this side was given. Oh, they had another angle that was given. Angle E is congruent to angle J. And then I found my vertical angles. Now I need to use three letters here. So angle EGF. That's this angle right here. Angle EGF and angle JGH. That's this angle right here. See how I listed my two angles and my side? That's how this works. So here's a side, and they're sharing a side. So if you look in each triangle, there's two S's and there's two S's. Well, SS isn't one on our list. This is not enough information. You cannot conclude. Right? There's just not enough. We don't know. Let's look here. Well, I see that they're sharing a side, so I'm going to put an S here for sharing side. And these, if you remember back a couple chapters ago, these arrows represent parallel lines. So I can't put an S there. That's not an S. Not an S. This is going to help me find angles. See, if I draw these lines as parallel, if you remember, these are called alternate interior angles. If you can see that, here's your transversal. So here's your angle, here's your angle. And then we can do that same thing in the other direction. If these lines are parallel, and this is your transversal, this angle is alternate interior with this angle. So what did we use on these two triangles? Is the side in between the A's? Yes, it is. This is angle, side, angle. So now we need to list all those things. We're using angle, side, angle. So we've got to list the angles on the side. So we had 1 and 3 were alternate interior, 2 and 4 were alternate interior, and they were sharing a side. WX, I believe, oh, I'm sorry, that's WZ, and ZW for the other one. So now here we're going to do the exact same thing, but we're going to write it out a little bit more formally. But it's the exact same thing as we've done on that last example. So I see a side. That's the same. That was given to me, so let's go find that. BD is here to BC. That is given. All right, and let's see what else. Oh, don't want to forget about my vertical angles. There's an angle. And that looks like it's right here. ABD is congruent to EBC. Yep. It's my vertical angle theorem. And the last line is always what I'm trying to prove. Triangle ABD is congruent to triangle EBC. So I've got an angle and a side, but what else? Well, this is a clue. This right here is a clue to help us. These lines are parallel, so let's draw them out more. If those lines are parallel, we could use this as our transversal. These are alternate interior angles. So I'm going to put an A there. Oh, right here. Here it goes. Alternate interior angle theorem. Oh, and then the last thing we have to do is list the rest of the givens. All right, so let's see. So here we talked about a side. This was our clue to help us find this angle. Then we found another angle. All right, so what did we use on our triangles? We used angle, side, angle. Notice that side is right included in the angles. Angle, side, angle. In example 4, how could you use angle, angle, side? Well, if we wanted angle, angle, side, the angle would have to be up here. We would have to use angle A and angle E as our alternate interior angles. Because if the A were up here, then it would be angle, angle, side instead of angle, side, angle. All right, the checkpoint is yours. You need to do this now. Does it give enough information? All right, so your choices are SSS, SAS, angle, side, angle, 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 side, or none, or no, not enough information. This is M Cubed, signing out.